For this first example video, I'm actually going to go through 4 separate examples of just slight variations of things that can pop up when trying to use the square root property. So similar to other properties that we've used in the past, we want to look at this and first of all say, are the requirements met to use the square root property? Do I have a perfect square on one side and a real number on the other side? And in this first case, we absolutely do. And so to use the square root property, we take the positive and negative square root of both sides, meaning that x equals the positive or negative square root of 50. Now that plus minus symbol that we have there means there's 2 unique answers. There's positive square root of 50 and there's negative square root of 50, but instead of writing them separately, we're writing it in the shorthand by saying I'm allowing both the positive and the negative answer. Now we don't want to leave the answer like that though, because of what we learned about radicals, that this can be simplified. So instead of 50, we want to simplify it by doing the whole break it up, take the radical, clean it up thing. And so the square root of 25 is 5. And so our answer is positive or negative 5 root 2. Now when you're entering this into our homework system, you do want to enter this as 2 separate answers. So we do have positive 5 root 2 as well as negative 5 root 2. And we just put a comma in between them. Now keep in mind that we do not want to put parentheses here. That would mean something completely different. That would mean I have an ordered pair where the x value is 5 root 2 and the y value is negative 5 root 2, or else it's going to mean we have interval notation, so we're allowing all the numbers in between, which is also not the case. So we just want to list this as a number, comma, another number. Now let's go ahead and take one small step up in difficulty. Let's look at 3x squared equals 21. And so if we again start off with, do we have the requirements? Do we have a perfect square on one side and a real number on the other? We actually don't. But we can easily get there by saying, I don't like the 3 that's there, so let's divide both sides by 3. And that's going to give me x squared equals 7. At which point we can apply the square root property to say, let's take the positive and negative square root of both sides. In our homework system then, we're going to enter that as positive root 7 and negative root 7. But if you're writing this on paper, the plus minus notation's perfectly fine as long as it can't be simplified. So I do want to point out that if we had an answer like 1 plus or minus 3, we wouldn't want to leave it like that, because remember what this means is it means 1 plus 3 and 1 minus 3, each of which we know the answer to, 4 and negative 2. So plus minus is perfectly fine as long as we don't know how to simplify both the plus and the minus. All right, let's take one more step up in difficulty. Do we have perfect square on one side, real number on the other? Yes. We have an expression that's squared on this left side. X plus 2 is being squared, so the requirements are met. So to use the square root property says, let's take the square root of the left side. When I take the square root, it just undoes the square and leaves me with x plus 2. On the right side, I take the positive and negative square root. At which point I can simplify this because 18 is 9 times 2, making this 3 root 2. Now my goal was to solve for x though, to get the x by itself. So I need to get rid of that plus 2. I would get rid of the plus 2 by subtracting 2 from both sides. This gets me x equals negative 2 plus or minus 3 root 2. Now again, it's perfectly fine to leave the answer like this in a handwritten form, but if we were to put this in the homework system, then we need to enter this as negative 2 plus 3 root 2, as well as negative 2 minus 3 root 2. So notice where the plus minus is. That's the only place that we want to make it plus for one answer and minus for the other. The negative 2 is negative 2 the whole time, so that stays negative 2. We're only changing where it's the plus minus. Let's look at one more example. For this one, we're going to use the square root property. It does apply again because we do have a perfect square on one side and a real number on the other. So that means we can take the stuff that I'm squaring and set that equal to the positive or negative square root of what's over there on the right side. Now, if you remember, we know how to take the square roots of negative numbers now. The plus minus stays, but the square root of negative 25 is 5i. We definitely will end up with I-type answers here. We're going to solve for x by adding 1 to both sides and then dividing by 3. So this is in fact two separate answers because of the plus minus, and those two separate answers are 1/3 plus 5/3 I, as well as 1/3 minus 5/3 I. And those are our two answers that we would input into our homework system.